here with R.Yager, and he's a hydrogeologist for the U.S. Geological Survey, and he's worked there for 30 years. Can you tell me about your education and how you became what you are today and what you do?
I went to high school in the 60s. I went to a suburban high school in New York, upstate New York, and then after I graduated I went to Cornell University for 4 years in an engineering school. And I studied what in those days was called environmental systems engineering, which was a brand new field. And then I took a long hiatus and went back to graduate school at Cornell in agricultural engineering and got a master's degree.
What did you do during your hiatus?
I worked in a variety of capacities. In between my jobs, I did some traveling in Mexico and Guatemala, and decided at one point that I needed to go back to school to do the kind of work I wanted to do.
Which was?
That's when I went back to Cornell to get the master's degree in engineering in water science, basically.
And what made you decide that you wanted to do water science as opposed to any other type of engineering that you had already previously studied?
I had, during my travels, I made acquaintances with Mexican families and stayed with them and spent time working with people, and in particular this one man who lived in a dry valley, in an arid valley in Oaxaca, Mexico, and where water was very important. And I saw the kind of projects that he was doing by himself to provide water to villages and farmers, and it seemed like an interesting endeavor and something that would help people. So that was I guess that's the root of my interest. Graduate school, I did 2 or 3 projects in Mexico. The first was actually a sanitation study, and I worked with a development agency there to try to come up with a better sanitation system for people that lived in these areas. And my first project was to research the alternatives, and I spent a couple months down there. Then presented my findings to them in a translated into Spanish, and they selected a composting toilet alternative to look at.
And so your report was just all the options that they had?
Yeah, I wrote kind of like the history of sanitation and what people were doing in third world countries and what might work and their benefits and drawbacks and so forth. And the development agency decided they would try building 5 composting toilets. I obtained some funding to go back, and I oversaw the construction, the design of the blueprints and so forth, and getting the materials, and they provided, the development agency provided the labor, and we constructed these composting toilets.
Okay.
And I went back a couple times to check on the progress. There was an architect for the agency who was the local manager of the project, and he continued to oversee it once I was gone. And at the same time I was doing that, I was obtaining documents, reports, technical reports for looking at the groundwater in the valley, that I was going to do another project, kind of like an independent study project of that subject. And when I got back to Cornell, it turned out that the composting toilet sanitation project was not really suitable as a thesis, but the groundwater study was. So I ended up doing the groundwater study for my thesis project and did a numerical model of groundwater in the valley.
And that's what you do now? That's
what I do now. And that's how I got involved with the U.S. Geological Survey, who happened to have an office in Ithaca, where Cornell is. And I visited the office to look for someone there that could help me put together this computer model. And it turned out they needed more help than I did, and they hired me. So
lucky you.
I've been there ever since.
So for the USGS, what kind of writing do you do in the capacity that you work in?
I started out primarily writing technical reports, which are most of the reports that the USGS produces are they're informational studies. They're aimed at while they're written for the public and distributed in libraries, they're primarily aimed for a technical audience, and they're highly detailed. They have a lot of information. They're fairly thick reports. We have other series like fact sheets, which are summaries of that. But most of the reports I've written for the survey are these technical reports, some of which are, if it's a very interesting study or innovative study, it's in a separate series which are aimed more at scientists, other scientists, than at the lay public or even governmental officials that might be interested in the subject matter. On the other hand, I'm in the research program, and so I also write journal articles. And again, these journal articles are primarily aimed at the scientific audience, not the lay audience. So I primarily write two types of reports or articles. The main difference between the two is the technical reports are longer. They're sort of like a thesis, whereas the journals articles are supposed to be shorter, more succinct, and you suppose a certain amount of a level of understanding on the part of the reader, so you don't have to explain everything.
Right. So what you do isn't meant for the public, kind of?
Well, I do two types of reports. One is meant for the public. The other is more aimed at the scientific community.
Okay. What were you taught in college in your years at Cornell, all of them, including grad school, in writing that is applicable to how you write today and what you write today?
Well, as an engineering student at Cornell, I did virtually no writing. I took one humanities course where we did some writing in my freshman year. And I'm trying to think, in undergraduate school, I don't think I took some courses in city planning, actually, and we did some writing in there, which is not obviously aimed at engineering.
Right.
Just research type papers. Yeah. And then for my graduate degree, I had to write a thesis. But beyond that, I would say virtually no writing, or very little writing.
Even in graduate school?
Right, because you're taking graduate engineering courses typically, at least in those days, didn't include much writing.
Right.
In the survey, we have our reports are highly edited. We have technical editors, and I would say I learned to write in the U.S. Geological Survey. So I write a certain style that the editors
have taught.
Foster.
Oh, okay.
Yeah.
So what do you wish you had been taught in college, or what do you wish you had come into your job knowing how to do as far as writing goes?
Well, today things are so different with the internet and web-based portrayal of information. The survey is struggling to portray its information on the web now, and making it more accessible to people, using more visual material than we were able to even with our technical reports have color illustrations and so forth, and have had for a long time, but they're still printed materials that cost a lot of money, so we're transitioning into preparing downloaded reports that people can download, and portraying information that people can look at in short bursts of time and not have to pour through the whole report. So, but in terms of writing per se, that's a difficult question. I'm not sure. Probably, I think the rule of writing is the more writing you do, the better you get. But you do need a third party to help you critique and to improve your writing, because everything you write to yourself looks perfect, but in reality it isn't.
Right. So tell me a little bit more about what you do in your capacity at the USGS.
Well, I'm a groundwater hydrologist. I'm classified as a research hydrologist, and what I primarily do is build computer models, numerical models of groundwater flow in large systems that supply water to communities as opposed to households or suburban developments. I recently finished a study of Carson Valley in Nevada, where we put together a groundwater model of the valley, looking at the effects of continuing residential development on water levels and basically how much water they could pump out of the ground. Another project I worked on was in the Shenandoah Valley, where they have similar concerns. Although it's not an arid area, there's much more development going on because it's closer to Washington, D.C. It's also a more complicated area because it's in fractured and folded sedimentary rock. And it's actually karstic, which means it has it's cave-forming rock. So the water moves through cracks in the rock as opposed to void spaces between sand and gravel particles, like in the Carson Valley.
Right.
So that particular project was interesting from a research point of view, as well as from a public point of view. So I produced both a technical report for the describing the groundwater model and estimates of the rates of flow and recharge of the groundwater. And then I produced a journal article that described the techniques that I had to develop to model the system. So there were two products out of that work, one aimed at the public and one aimed at the scientific community.
I know that you travel and give talks in conferences around the world. What kind of things do you present on? Is it like, do you present about those projects that you just do, or like modeling, or? Yeah,
at scientific conferences, the emphasis is on innovation in the field. So typically, people that attend the conferences want to know about new findings, new techniques. So my most recent conference I attended was in France this fall, and there we talked about how we used environmental tracers, which are things that are in the chemicals that are in the atmosphere. They're put there by man-made activities that enter the groundwater and move through the groundwater.
Like what, for example?
For example, tritium, which was derived from nuclear testing in the 60s, which is still in the atmosphere today. There are chemical compounds called CFCs, which are chlorofluorocarbons, which were from refrigerants that were produced during the last 20, 30, 40 years. So we look at concentrations of those compounds in water, and you can determine from that, if you're lucky, the age of the water, how long it's been in the system, which tells you something about how fast the water is moving.
And how fast it's being taken out by human populations, or?
Well, that's part of that's information that you need to calibrate or develop these groundwater models to make them more accurate. So once you know how fast the water is moving, how much is entering, you can characterize pretty completely how much water is in the system.
Right.
So at the conference, I talked about how we utilize those environmental tracer techniques in the development of the model in this fractured folded rock.
Cool. What does it take to efficiently convey your research and conclusions that you find to the public so that they understand? And do you think that you personally and the USGS as a whole does a good job of it?
I don't think the survey does a particularly good job of conveying our information to the public. We do a very good job of conveying it to the scientific community, the regulatory agencies, the people that hire us to do the work that we're doing. Getting the information to the public, on the other hand, is a different story, and most people in the country don't know anything about the U.S. Geological Survey or what we do. So right there you can see that we don't really do a very good job of displaying information, with the exception of the people that work on volcanoes or earthquakes, where occasionally USGS people will be on television interviewed after some catastrophe. But we actually, for example, we do flood monitoring, stream flow monitoring. In the recent Hurricane Sandy in New York City and New Jersey. They were USGS crews measuring the height of the storm surge, which is very important information for predicting the impact of future events. We don't really get much credit for that information. I mean, that information is used for other agencies, and typically the USGS, who is the seat of that information, doesn't even get mentioned. So what we're trying to do is make ourselves a little bit more known, which is important in this era of restricted funding. Utilizing the internet and preparing primarily shorter, more accessible reports. These fact sheets that are 4 pages long and glossy with pictures, and they're summaries of what we do. They don't have much detail, and but on the internet, on the other hand, you can incorporate all kinds of information and levels of depth, so people can mine to whatever level they're interested in. But that's a very new area that I personally don't know too much about.
It was very interesting to learn what you do. Thank you for talking to me and being interviewed.
You're welcome.